Hello and welcome to the Outback Power webinar series. Today we'll be talking about new requirements for grid interconnected inverters, specifically the SunSpec Common Smart Inverter Profile, or CSIP requirements. My name is Bo McGlee and I'm Director of Product Management here at Outback Power. Thank you for joining me. Okay, so our agenda for today. Why are we talking about this? What is the SunSpec Common Smart Inverter Profile, or CSIP? What is California Rule 21, specifically phases 2 and 3? And when will this affect me, both in the state of California and outside of the state? So who does this affect? What Outback Power is doing? And then we'll spend a little bit of time talking about FAQs and wrap up with a summary. So why are we doing this? It's because the grid is changing and it's driving these new requirements for grid interconnection. If you go back to 1880 when the grid was first developed or first evolved, it was very much a centralized control and command type architecture, one-way flow of power and information. So some of the key features: large-scale central generation. You'd have residential, commercial, industrial loads all served from the grid only. So there was no self-generation. At the time, surplus generation capacity was required from the utility company to serve variable loads, and then the grid operator had to balance their generation with both actual and anticipated loads, again, centralized. So other forms of generation have been added over time. We see in 1978, PURPA, the Public Utilities Regulatory Policy Act, introduced this concept of non-utility generators and encouraged efficiency, cogeneration, and renewables, hydro in particular. And then in 1990, you see the Clean Air Act amendments setting standards for stationary source emissions, and really foreshadowing this GRID 2.0, as well as you see deregulation emerging as the model of the 1990s. And so you see this rise of distributed energy generation, rise of renewables, and two-way power flows. Some of the key features of GRID 2.0, many central generating plants are starting to be decommissioned or retired. You see distributed generation creating two-way power flows. You see a lot of new initiatives around load management, demand response, and you start to see some storage being present. So we're going to see grid operators begin to adopt market mechanisms or merchant services to balance their loads with generation. And then on a bit of a shorter time scale, you go back to 2010, and I picked that date on purpose. We see solar plus storage increasing, and that's driving changes to the interconnection standards. So back in 2010, you see UL 1741 inverters like the FXR coming online. You see a modest number of solar being installed in neighborhoods on people's homes. Fast forward to 2016, and we see a real focus around grid stability. So you see inverters like the Radian, the first battery-based UL 1741 SA inverter being released, and or you see this, the SA functionality being added to inverters like the Radian. And then fast forward to 2020, you see a lot more and more neighborhoods and the substations that serve them with a large number of renewables on them. And you see a trend towards more advanced, more grid interconnected inverters coming onto the market. Okay, so what are the changes that we're seeing to the interconnection standard? Well, again, 1741 was introduced in 2010. Fast forward to 2016. SA, or Supplement A, which carried with it references to IEEE 1547, the Grid Interconnection Standard 2003 edition, and then the test standard released 2 years later, the 1547.1, requiring grid interconnectivity, requiring ride-through and that sort of thing. And then what the UL group is working on right now with input from industry is 1741 SB, or Supplement B, and that's going to have direct references to 1547 2018 and 1547.1 2020. So going forward, we're going to see inverters certified via both UL 1741 SA and UL 1741 SB. And that's going to give markets like California, like Hawaii, like ICE New England, time to update their tariffs while new products start to appear on the market that address these requirements. So The market will start to get access to the new 1547-2018 capabilities prior to when they have to for mandatory compliance deadlines. And there are some or a lot of customers who are asking for this now. So what are some of the impacts we're going to see with 1741 Supplement B? Well, we're going to see customers who install their distributed energy resources who may see shifts in their distributed energy generation output under certain scenarios. And that might require adoption of new consumer protection measures. We'll see changes in the interconnection process used for distributed energy resources connecting to the grid. And that's going to need to be updated to reflect the new standard and to reflect the vastly different conditions under which the grid is operating today as compared to 2003. So any current state rules with utility interconnection procedures that are based on the IEEE 1547-2003 standard will need to be updated to reflect these recent revisions. Let's see, I'll go on to a quote from the IRAC President CEO Larry Sherwood. Larry says that with the IEEE standard 1547-2018, which has been published, we have a few remaining years before full rollout 2022. And now is the time for states and regulators to begin to implement the updated standard. He goes on to state that even in states where DER penetration is low today, this is going to help ensure that distributed energy resources meet the most updated performance standards while giving latitude to utilize the enhanced grid functionality as volume of distributed energy resources increases on the grid. States or utilities will begin to integrate these IEEE 1547-2018 standards into their applicable interconnection rules and tariffs voluntarily or as directed by state statute. We're going to talk about that on the next slide. But we're entering a period of transition, so we're going to see multiple utilities today requiring 1741 SA, and it'll take time for them to change their tariffs to require 1547-2018. And then the mandatory compliance dates are going to vary. And then the market pull or desire for 1547-2018 products that exist today, we're seeing that on RFQs, RFIs, and we're going to see that UL 1741 SB is going to provide a path to certification for 1547-2018. And that's going to be released soon here. Now, older legacy products can just keep their 1741 SA and sell into less progressive markets because not all markets are going to require Supplement B, just the big growing progressive markets in the future. So what does this look like with respect to implementation timing for both UL 1741 and IEEE 1547-2018? Well, let's see if I can pull up a laser pointer. Okay, so 1741 SA was released in 2016, excuse me. We saw phase 1 of California Rule 21 out in 2017, and then we published as an industry 1547-2018. California Rule 21 phase 2 requirements were originally beginning with 2019. Those have now moved to be required for new interconnect applications starting as soon as March 22nd. And then full 1547.1 2020, full 1547-2018 enforcement is anticipated in 2021 through the end of 2022. We're already seeing example enforcement dates, for example, with Minnesota and Maryland. So why does it matter now? It matters right now because California's changes to Rule 21 that go into effect potentially again as soon as March 22nd of this year. Phase 2 requires distributed energy resources to support the SunSpec CSIP 2030.5 communications protocols. We'll talk more about what those are in the subsequent slides. Phase 3 requires a new attestation for all grid connected inverters, and that attestation includes compliance to 2 advanced functions for both monitoring and scheduling. And many states aren't waiting for widespread adoption of IEEE 1547-2018. You see Vermont's Bring Your Own Device Energy Storage Program for Green Mountain Power. They're not specifically calling out 2030.5 functionality, but they're not the communications protocol, but they are calling out the same sorts of functionality that 2030.5 brings you. Similarly, you see Massachusetts with its SMART program, which pays solar customers for each kilowatt hour produced and incentivizes energy storage as part of the mix. We know that Hawaii is exploring dispatchable generation from renewables and an update to 14H, and it's going to reference 1547-2018 as much as possible. Similarly, New York has its Reforming the Energy Vision, or REV. And then going back a little bit further, you see that Arizona, APS launched its Solar Partners Program way back in 2014 to deploy and remotely control advanced inverters at customer solar sites to manage those resources for grid services. Okay, switching gears a little bit into some more technical meat. What is the SunSpec Common Smart Inverter Profile, or CSIP, and what's it going to do for us? So it's a configuration requirements that are described in the CSIP. And according to those configuration requirements, an inverter or a distributed energy resource must use IEEE 2030.5 2018 communications protocols, must have secure communications between the inverter and the grid, must have monitoring data, including mirrored metering function sets for posting metered data, must have log even functions for alarms and response function sets for event acknowledgement. Also includes scheduling requirements, which address both effective start time, end time, and must have only one active event per client or per distributed energy resource. So this is all leading towards support for eventual utility control to proactively support the grid. This is not just specified power factor, volt var, frequency, or volt watt like we see at 1741 SA. In many ways, this is more invasive for the inverter, for the battery. And then products certified to SunSpec for 2030.5 standard for wide area communication can be installed with a large degree of confidence that they will be safely connected to the California investor-owned utilities, and you can have that confidence in their capability to communicate over local area communication protocols like the freely available SunSpec model standards. So how do we get here? We got here through the Smart Inverter Working Group, or SIWG. That grew out of a collaboration between the California Public Utilities Commission and the California Energy Commission way back in 2013. And we identified that the development of advanced inverter functionality is an important strategy to mitigate the impact of high penetrations of distributed energy resources. And so we pursued the development of advanced inverter functionality over 3 phases. So it would be implemented over time. Phase 1 considered autonomous functions that all inverter connected distributed energy resources in California were required to perform. Phase 2 considered the default communications protocols between the investor and utilities, a distributed energy resource, and distributed energy resource aggregators. And then phase 3 is currently considering additional advanced inverter functionality that may or may not require communications. And there are 2 of those functions, 2 of those 8 functions in phase 3 that we have to support now. We'll cover that in a couple of slides. So here's what the roadmap looks like. This is the road that we've been on for California Rule 21. Phase 1, again, was these autonomous functions, or what we think of as introducing smart inverters into the marketplace. Phase 2 brings us communications protocols. Phase 3 brings us advanced functions. So what were the hallmarks of phase 1? I believe everybody on the call and listening to the webinar is familiar with these, but we'll touch them at a high level. It's providing anti-islanding, keep alignment safe in case of grid outage. It's providing ride-through for both low and high voltage and low and high frequency. It's doing ramp rate setting, providing dynamic volt var functions, fixed power factors, a soft start, volt watt control, and frequency watt control. What are we getting with phase 2, these communication protocols? Well, we're getting synchronization with the national code, IEEE 1547, and we're getting a SunSpec Common Smart Inverter Profile, or CSIP test procedure that's been approved. We're starting to see smart inverters being certified for compliance. We believe that we're going to see interconnect applications that must select a CSIP smart inverter after the deadline of March 22nd. And we're starting to see 2030.5 DER aggregator testing certification coming on the market. So again, it's compliant products coming to the market now. Phase 3, some of the advanced functions. So we've implemented 2 of these already. Function 5 and function 6 for the freq watt mode and the volt watt mode. We already did those last year. What's new now and required as part of the attestation is function 1 and function 8. That's monitoring of key data, and function 8 is setting power modes and values. It's really scheduling those power modes and those values. And then we believe functions 2 and function 3 are going to be coming along shortly. Functions 4 and 7 are 12, maybe perhaps as many as 18 months after we see the nationally recognized standard updates for 1547. So what's going to happen once we have phase 3 of these advanced functions? Well, we may see that utilities begin issuing event schedules for active and reactive power values, as well as setting power modes and other changes for the inverter for the battery system. We're going to see that distributed energy resources must report system data to their utility. Even if the utility isn't ready to receive those reports yet, the distributed energy resource must be able to at least send those reports. And then each distributed energy resource is responsible for daily subscriptions to all applicable utility channels, and they're responsible for the ability to receive scheduled commands from the utility. And in some cases, for emergency situations, it may be a 15-minute minimum or maximum response time required. So who does this affect? Well, according to Green Tech Media's research for how much in the US annual residential energy storage is going to be deployed this year, next year, and in 2022, it's as much as 800 megawatt hours of grid-connected residential energy storage to be installed this year in places like California, Massachusetts, Vermont, Minnesota, Oregon, Maryland, etc. And then as much as 3,800 megawatt hours of grid-connected residential energy storage to be installed in 2021 and 2022 in every US state as the IEEE standard for 1547-2018 is adopted. And let us not forget our friends north of the border, Canada too. We've already seen pilot programs having been started, pardon me for conjugation, in Ontario and Quebec. And IEEE 1547-2018 adoption is also going to complete in Canada no later than 2022. Okay, that was a lot to digest and consider, so we'll change gears slightly. Can I just opt out? No. I mean, sure, if you live here, right? If you only install off-grid, then this information isn't for you. But for all of the rest of us, all of this matters. So what's Outback Power doing? Well, we're releasing 2 SunSpec 2030.5 CSIP certified products. And those are Skybox. So any Skybox shipped with firmware version 1.5 and above supports 2030.5 communications. And then we're also releasing a CSIP Bridge product. That's going to enable FXRs and radians with a Mate 3S to support this new communication protocol. And they're going to need to have Mate 3S firmware version 1.4.3 and above required in order to do that. So what does this product look like? There is a much greater than life size image of it. We have actual nice publicity shots that we're working on, but we had to update the logo a little bit to be able to publish those finally. But you know, here's our schematic and our drawing of it. It's a little communications device, a bit smaller than a Mate 3S if you're familiar with one of those. Here's the overview on it. So that it allows secure communications from the Mate 3S and either a Radian or FXR to the utility company. It plugs into the homeowner's network just like the Mate 3S does. It just needs Ethernet and AC power. So it doesn't need to be located anywhere near the Mate 3S. It just has to be installed on the same network. So it's compact, connect anywhere design. It allows it to be installed almost anywhere and forgotten. I mean, you have to put it indoors and it has to be on the same network as the Mate 3S, but other than that, it's pretty simple and easy to install and simple to reconfigure if needed. And then it has a couple LEDs on the back or on the bottom of it to indicate device status. Okay, let's train everybody up on how to be a CSIP Bridge installation expert. It's a simple 5-step installation. Step 1, connect any computer to the same homeowner's network as where the Mate3S is currently connected, and then connect your CSIP Bridge to that computer. So you use the Outback provided USB cable to connect the CSIP Bridge to the computer. Let the start auto script run. That brings out a 2-page configuration. So you just click the buttons, type in the information here, and then unplug the CSIP Bridge from the computer. And then finally connect it into the network via the provided Ethernet cable, and don't forget to power it off. We include our own handy AC adapter for that. So in summary, the CSIP Bridge is fully compliant, certified to SunSpec 2030.5 CSIP. It's secure, it comes with a device-specific and unique security key, which is installed in the factory. That's really important for those secure communications back to the utility company. Very easy setup and installation, and then full instructions, product information will be available at the website listed there on your screen. So some of the FAQs. Okay, so this is a bit of an alphabet soup. We've recognized that. What's the difference between SunSpec, CSIP 2030.5, California Rule 21, Phase 2, and IEEE 1547, 2018? Okay, so starting at the top, SunSpec is an alliance, a trade alliance of more than 100 solar and storage distributed energy participants. Together, we're pursuing information standards to enable plug-and-play system operability. And so in order to do that, we came up with this CSIP standard, this common smart inverter platform and the requirements therein. What we decided as part of that effort was that we would mandate, today at least, that we use the IEEE 2030.5 communications protocol for secure communications. And in future, the groups that are working on IEEE 1547.1 2020, test requirements there. There may be some additional standards that are added to that, but today we're all sticking with, as an industry, standardizing around this IEEE 2030.5 communication standard. And that's just a means of transferring bits and bytes from one place to the other in a secure fashion. Okay, so California Rule 21, Phase 2 is the California Public Utilities Commission's mandate for grid interconnected inverters in the state of California. And that's Phase 2 is specifically around the communication protocols that specifies that we must have a SunSpec CSIP protocol. And then nationwide, we'll see changes to IEEE 1547 and the test requirements therein for grid interconnectivity. So is all of this related to SCHIP? Well, yes, it is. The California Self-Generation Incentive Program going forward is going to require that the inverters that are enrolled in that program have 2030.5 communications, that they are SunSpec CSIP certified. So insofar as that there is a shared requirement there, or that in order to get one, the SCHIP incentive, you have to have the other, the SunSpec CSIP communications protocol. Yes, they're related. They are, however, different things. Should I stop doing grid interconnected installs? Oh my goodness, no, please don't stop doing grid interconnected installs. But we do have to be careful, especially in this time of transition, about what the interconnection requirements are going to be from the utility, and make sure that we have the products available to be able to meet those requirements. So do I, as an installer, need to do anything? Right now, I would absolutely recommend reaching out to your distributors and checking to see what they have with respect for available products that meet these new interconnection requirements. Okay, so in summary, Outback has available soon the CSIP Bridge product that's already on our price list, and that's available for the Radian and the FXR. Now, it requires a Mate3S as well, and it requires a Mate3S be running firmware version of 1.43 and above. And then also available soon, we'll have Skybox with firmware version of 1.5 and above. So Outback Power is going to be offering 2 products, which are SunSpec Common Smart Inverter Profile, or CSIP certified. And we believe from everything we're hearing that that's going to be required on all grid-connected, grid interconnection installations in the state of California, potentially as soon as March 22nd, 2020. Now, I'll caveat that, and I'll close with one final thought. When are we really going to need it? To be honest, we don't know. Like, we're a SunSpec member, we're on the Smart Inverter Working Group, we talk with utility companies frequently, and we don't know when this is going to be required. I hope the utilities are going to roll this out in a reasonable and a manageable fashion. I hope the utilities are going to communicate the requirements clearly to installers as they are starting the permit process and starting those discussions around grid interconnected distributed energy resources. But so far I haven't heard about, when this is going to be adopted or when it's going to be officially enforced and what exactly that's going to look like. So we're doing everything we can in the meantime to prepare for those eventualities and make sure that people have what they need to be able to meet those requirements. So again, thank you for your time. And I'm Bo McGlooyan, Director of Product Management here at Outback Power. And stay tuned for our next webinar in 2 weeks on UL 9540 and some of the building code requirements around installing storage in your home. Thank you much.